We're going to take a quick look at the periodic trends on the trends on the periodic table. All of these are based on the number of valence electrons, electrons that are in the outermost energy level. So all atoms want to have a full outer energy level, meaning the s&p orbitals, because when you go through and do an electron configuration, the highest numbers are always going to be the s&p orbital, and they're always going to match for the outermost energy level. So electrons will gain or lose electrons in order to be able to get to a full outer shell. If you have 1, 2, 3, or 4 valence electrons, so electron configuration through s, let's say 3s2, 3p2, so that'd be 4 valence electrons, it's easier to lose those 4 than it is to gain. Elements that have 5, 6, or 7 will gain electrons to get to a full 8. So you're talking about either you're going to gain electrons to get to 8, a full s&p orbital, or you're going to lose electrons to get to a full s&p orbital. Okay. For the trends we're going to look at, the first one we're going to look at is atomic radius. That's just this distance from the center of the nucleus out to the outermost electrons. And in a period, as the number of protons increases, the radius decreases. Meaning, as we look across a row, the smallest atoms are going to be the ones on the right-hand side. The reason being they all have the same number of energy levels in a row, or in a period. And so the one on the furthest right has the most number of protons for relatively the same number of electrons. As you go down the periodic table, the atoms get bigger because you're adding in a different energy level. And we're going to draw this out on the periodic table in just 1 second. For ionic size, we need to know that it decreases and then it increases again. Basically, you have 2 types of ions. You have a positive ion, which is called a cation, and you have a negative ion, which is called an anion. Cations, positive ions, the more positive you are, meaning you lose more electrons, the smaller you get. Anions, which are negative ions, meaning you're going to gain electrons, the more electrons you gain, the bigger you get. So if you're looking at ions, we go all the way from -3 ions are the biggest negative ones. Those would be the biggest. So something like nitrogen that always forms a 3- ion would be the biggest. All the way to things that form 4+ cations, something like carbon that will lose 4 electrons. That's going to be the smallest because it lost 4 electrons compared to what it normally does. For ionization energy, it's the energy needed to remove an electron. So this is directly related to size. The smaller the atom, the harder it is to remove an electron. So the smallest atoms are the ones in the top right of the periodic table, so something like fluorine, and that's going to have the highest ionization energy. We kind of ignore the noble gases because they don't react with anything and they don't form ions. So we just focus on the things that are in groups 1 through 7 of the representative elements. Electron affinity is the energy needed to get a full outer energy level. We're not going to spend too much time with it, but the highest electron affinity is, again, the smallest atoms on the top right, and the smallest is in the bottom left. Electronegativity we're going to spend some time with when we do bonding here in a couple weeks, but it's the ability to attract electrons in a bond. The smaller atoms up in the top right, again, have a higher electronegativity. The ones in the bottom left, the big atoms, have a very low. All this basically means both electron affinity and electronegativity is the ones in the top right really want to keep their electrons. The ones in the bottom left that are really big really don't care if they lose electrons. So the easiest way to see these trends is to kind of write them out on the periodic table. So as we look through here, it works really well just to draw arrows. So we're going to draw atomic radius first. So the smallest ones are in the top right. And we're just going to draw an arrow down this way. And we're going to say increasing radius. So that's the way that works. Now all the other ones kind of work opposite in that the arrow going this way, we're going to say increasing electron affinity. That really doesn't look like electron, but it is. Increasing electron affinity and also increasing electronegativity. The other thing that we talked about was the ion size, and we're not going to be able to draw that out on here, but I can show you what ions they form. Everything in this group forms +1, everything in this group is +2, everything in this group is +3, everything in this group is +4. These are 3-, 2-, 1-. Remember, the most negative is the biggest, the most positive is the smallest. So we're going to talk more about that coming up here in the future, but for right now all you need to know is the more negative you are, the bigger you are, the more positive you are, the smaller you are.